Hello everyone, thank you very much for signing in and watching my live stream. I'm Mr. Matt and this is Dr. Tot. Dr. Tot, do you want your cookie? There you go. And welcome to Geometry. This week and next we're going to be concentrating Monday through Friday in our regular slot on our regular time slot on preparing for the semester A exam that's coming up. So I've divided the curriculum into 10 clusters and we're going to go through one today. I want you to use these sessions along with the practice exam, the first practice exam 1 that I'll be posting shortly, as diagnostic tools. You want to use them to identify areas in which you need improvement. You shouldn't use these as a substitute for your own teacher's individual review packet. There are some areas, some subtopics that your teacher may have included or not included, depending on the time constraints of the particular semester you're talking about. So you want to use your own particular teacher's review packet as a reference, but this is to supplement and to provide you extra examples and help wherever you may need it. These sessions obviously are live, so you're more than welcome to sign in and ask any questions that you might have. Also, you're welcome to comment below or contact me on social media. All of my addresses are listed in the description. And so if you have any recommendations on some problems that you're having difficulty with and you haven't found any videos to help you out, feel free to send them over and I'll take a look and make a video for you. But otherwise, today in our first cluster, we're going to be looking at calculating the missing segments or missing portions of a line segment. We're going to be using the midpoint formula and the distance formula, and also calculating some shapes on a coordinate grid. Let me go ahead and share my screen with you. And just a reminder, these are live sessions, so there's a little bit of a delay with the iPad, but I'll mitigate that as much as possible by watching the live stream. So this document is going to be available on Certified Learning Center's website. Just make sure that you're looking at the document with the reference number 2049-4. If you're watching live, it's not posted yet, but it will be posted very shortly. But otherwise, let's just go ahead and get into some of these problems. So number 1, we want to determine the length of the missing line segment for parts A and B. So A says line segment AC consists of line segments AB and line segment BC. If AC is 10 and BC is 4, what is the length of AB? B asks line segment AC consists of line segments AB and line segment BC. If line segment AB is 10 and line segment BC is 4, what is the line segment? What is the length of line segment AC? So I'll give you 3 minutes, and 1 minute in, I'll start to solve to give you some hints. Okay, so for number 1, or 1A I should say, so if we know that line segment AC is 10, that means the whole thing is 10, and one of its parts, or one of its components, is 4. So the missing part is going to be the difference between the whole value and the known part. So the whole value minus the known part will give you the missing part. So 10 minus 4 is equal to 6, and 6 is the answer for the length of line segment AB. Conversely, for 1B, here they gave you the two parts and then asked you for the whole. So the first part plus the second part will equal the whole value. So the first part is 10 plus the second part is 4. So the whole value, or the length of line segment AC, has to be 14 units long. If you have any questions, then please let me know. Otherwise, let's look at question number 2. Here I'd like you to find the midpoint between the following points. A is the point 3, 5 and the point 7, 5. And B is the point 2, 4 and the point 6, 10. I'll give you 3 minutes and I'll start to solve 1 minute in. Okay, so I gave you the midpoint formula there. Basically, it's just the average of the x and y components of the coordinates. So you just take the 2x coordinates, add them together, divide by 2. Take the 2y coordinates, add them together, and divide by 2. For A, you could have also realized, however, that these two points, you see how they have the same y value? That means that this is a horizontal line, and so the midpoint is necessarily, because there's no slant to it, with horizontal and vertical lines, it's really straightforward to find the midpoint because it's exactly halfway between the two endpoints. And because there's no slant, it's either vertical or horizontal, you can pretty easily discern that between the two endpoints. You just take the final minus the initial and you can divide by 2. But here, if we wanted to use the formula, then we can say that 3 plus 7 over 2 is the new midpoint's x-coordinate. So 14 over 2 is 7. Oops, excuse me, 14 over 2. That should be 10 over 2. My apologies. So 3 plus 7 is 10. 10 divided by 2 is 5. My apologies. That should be 5 comma 5. I'm sorry. So if we take 3 plus 7 divided by 2, that's going to be 10 divided by 2, which is 5. If we take 5 plus 5, that's also 10 divided by 2, is also going to give you a y-coordinate of 5. So the answer to 2a was 5 comma 5. For 2b, if we take the coordinates, the x-coordinates of 2 and 6, add them together, and I don't know what was going on here. I'm sorry. I had a little bit of a moment there. I don't know what's going on. 2 plus 6 is not 12, it's 8. 8 divided by 2 is 4. Just make sure I'm doing all these. Okay. Multiplying where it should be adding. My apologies. So 2 plus 6 is 8. 8 divided by 2 is 4. If we take the average of the y-coordinates, we're going to have 4 plus 10, which is 14, divided by 2, which is 7. So the answer to 2a was 5 comma 5, and the answer to 2b was 4 comma 7. If you have any questions, then please let me know. Oops, I'm sorry. Minimize my screen there by accident. If you don't have any questions, then please let's go on to number 3. So question 3 involves the distance formula. So I'd like you to calculate the distance between these two pairs of points. I'll give you 3 minutes. After 1 minute, I'll start to solve, and I'll write the actual formula here for your reference. So these two pairs were a little bit, little tricky because it seemed counterintuitive for them to be the same answer, but actually it is. So for number one, for number 3a, we can insert x2 of 5 minus x1 of 1. So 5 minus 1 is 4. 4 squared is 16. And then for y2, 8 minus y1, 8 minus 2 is 6. 6 squared is 36. 16 plus 36 is going to be 52. So we're going to have a distance of the square root of 52, which is about 7.21. 3b actually ends up being the same distance because the x-coordinates have a difference of 6. 9 minus 3 is 6. 6 squared is 36. The the y-coordinates have a difference of 4. 5 minus 1 is 4. 4 squared is 16. Again, 36 plus 16 is going to give you 52, and the square root of 52 is about 7.21. So if you got the same answer, that was intended to be a little tricky. But just to show you that it is possible for them to be the same distance, it's usually not. They're usually going to be different values on the exam. If you have any questions, then please let me know. You do need to memorize the distance or the midpoint formula unless your teacher explicitly says that he or she is going to give it to you on the exam. Let's look at question 4. Question 4 asks, calculate the area of the following shapes. So we have a rectangle with vertices of 3, 5, 3, 10, 15, 10, and 15, 5. We have a triangle with the vertices of 4, 2, 5, 8, and 8, 2. And then we have a square with the vertices of 2, 4, 8, 4, 8, 10, and 2, 10, excuse me. So I'll give you, I'm going to give you a little bit more time for this one. So I'm going to give you 4 minutes. Actually, I'll give you 5 minutes. Let me give you 5 minutes. After 2 minutes, I'll start to solve. Okay, so for 4a, we have a rectangle with the vertices 3, 5, 3, 10, 15, 10, and 15, 5. Notice how two x coordinates and two y coordinates are being repeated. That has to happen if these guys are going to, be, well, at least if they're horizontal or perfectly horizontal or perfectly vertical with the grid lines. And I wouldn't expect you to see skewed shapes here, though it's possible. But what you're really looking at is the differences between the endpoints. For the width, for 4a, we need to calculate the width and the length in order to determine area of a rectangle. The width here, you can look at the 2 points either on the left or the right. We have y coordinates of 5 and 10. So we went a distance of 5 units. So we know the width is equal to 5. The length on the x coordinates, we went from 3 to 15. That's a change of 12 units. So the length of the rectangle is 12. So the area is going to be length times width, 5 times 12, which is going to give us 60. For 4b, we have this triangle with coordinates 4, 2, 5, 8, and 8, 2. We need the base and the height in order to calculate the area of a triangle. The base here, since it's sitting horizontally on this grid line, we can tell that it has the same y coordinates of 2 on the base, so we know that that line's horizontal. The distance there is then just the difference between the x coordinates of 8 and 4. 8 minus 4 is 4, so the base of this triangle is 4. The height is the difference between the y coordinate of the apex and the y coordinate of the points at the base. The apex has a y coordinate of 8. The bases have a y coordinate of 2. 8 minus 2 is 6. So the area of this triangle is equal to 1/2 base times height. So we're going to have 1/2 times 4 times 6, which is going to give us 12. And lastly, for C, we have a square with the vertices of 2, 4, 8, 4, 8, 10, and 2, 10. If that kind of threw you off when you were graphing, that's because originally I was kind of labeling everything in a clockwise manner, and now I switched the direction, so I was going clockwise around the square, counterclockwise rather around the square. But remember, a square has equal sides, so we really only need to do this length calculation once. If I pick any of the coordinates, let's just look at the y's. We have 10 minus 4. 10 minus 4 is 6. So the side lengths of this square are 6, and the area of any square is just side length squared. 6 squared is going to give us an area of 36 square units. If you have any questions, then please let me know. Otherwise, let's look at question number 5. So I'd like you to determine the length of the missing line segment. Question A asks, line segment DF consists of line segments DE and EF. If DE is 6 and DF is 14, what is the length of EF? Question B asks, line segment DF consists of line segments DE and EF. If DE is 12 and EF is 8, what is the length of AB? Oh, excuse me, what is the length? That's a typo there. So we have DE and EF. What is the length of DF? My apologies, that should be DF. Okay, I'll give you 3 minutes. 1 minute in, I'll start to solve. Okay, so for number 5A, we're given the whole value of the entire line segment, and then we're given a portion of it, DE, as being 6. So the missing part is going to be the whole value minus the known part. So 14 minus 6 is going to give us a missing part of 8. So line segment EF has to be 8 units long. For 5B, we're given both parts and they're asking for the whole value, so we're going to add up, sum the parts. 12 plus 8 is 20. If you have any questions, then please let me know. Otherwise, let's look at 6. So again, we're going to be calculating the midpoint. I'm going to give you 3 minutes, and I'll start to solve after 1. Okay, so calculating the midpoint, we're literally just taking the average of the x-coordinates, comma, the average of the y-coordinates. So for 6a, the x-coordinates are 5 and 13, so I'm going to have 5 plus 13 divided by 2, comma, the y-coordinates are 6 and 12, so we'll have 6 plus 12 quantity divided by 2. 5 plus 13 is 18, 18 divided by 2 is 9, 6 plus 12 is 18, 18 divided by 2 is also 9. So the midpoint here is going to be 9, comma 9. For 6b, we have negative 9 plus 7, quantity divided by 2, comma 11 plus 15, quantity divided by 2. Negative 9 plus 7 is going to be a negative 2. Negative 2 divided by 2 is a negative 1. 11 plus 15 is going to be 26. 26 divided by 2 is going to be a positive 13. So our answer for the midpoint of 6b is going to be -1, 13. If you have any questions, then please let me know. Otherwise, let's look at question 7, and this is going to take us up to the end of class today. I'm going to give you 3 minutes. I'd like you to please use the distance formula to calculate the distance between the following 2 points, or 2 pairs of points, I should say, 8, 3 and -6, 9, as well as 4, -6 and -12, 8. Okay, so looking at these guys, the formula for the distance between any 2 points is the square root of the quantity y2 minus y1 squared, quantity squared, plus x2 minus x1 quantity squared. Doesn't matter if you put the x's first or the y's first, but they have to go together. You can't interchange. Don't subtract an x from a y or vice versa. They have to combine together by subtraction and then squared. So for 7a, if we do 9 minus 3, that's going to be 6. -6 minus 8, we can do leave, change there. Leave the first sign alone, change the operation, change the sign of the second number. -6 plus a -8 is a little bit easier to think about than a -6 minus a +8. So that's going to give you a -14. So -14 squared is 196. 196 plus 36 is 232. The square root of 232 is about 15.2. And 7b, we're going to have 8 minus negative 6. So two negatives will make a positive next to each other. You could also leave change here. Leave the 8 alone, change the operation, change the sign of the second number. So notice that positive 8 minus a negative 6 is the same thing as positive 8 plus a positive 6. That's going to give you a positive 14. Negative 12 minus 4. Leave the negative 12 alone, change the operation, change the sign of the second number. Negative 12 plus a negative 4 is a little bit easier to think about, so that's going to be a negative 16. Negative 16 squared is 256. 14 squared is 196. 196 plus 256 is 452. And the square root of 452 is about 21.3. If you have any questions on anything that we've done today, then please let me know either in the comment section below, or you can message me on my social media. If you have any recommendations for something that's troubling you on this exam, then let me know as well. And if you find these videos helpful, then please subscribe, like, and share with your friends. But otherwise, you all did a great job. Dr. Tot, you want to say goodbye to everybody? Yeah? Come on. You got to say bye. Can you sit? Can you say bye? Very good boy. Good boy. All right. Thank you guys very much for signing in. I hope you have a wonderful night, and I'll talk to you all tomorrow.